Today we're going to continue our study with trigonometry, but this time we're going to work things a little differently. I'm going to give you two sides and an angle and ask you first to find a given angle and then finally solve the triangle. So again, SOHCAHTOA is key, and so is Pythagorean's theorem. So the first thing that I want you to do with your notes, when you're solving it for a particular triangle, you want to label your sides using opposite, adjacent, hypotenuse. And finally, you want to show what trig function you're using. Okay, so if I was looking for this angle here, the side opposite it is called the opposite, and the side across from the hypotenuse, or I'm sorry, across the right angle is called the hypotenuse. So when you want to try to find an angle, we're going to have to use what trig function? Well, opposite and hypotenuse is the sine function. So watch what I mean by putting the sine trig function that you're going to use. So the sine of theta equals opposite over hypotenuse. Now what we need to find here is we need to find theta. So what we want to do, in essence, is get rid of this sine. Well, sine has a particular function. To get rid of it, we're going to use what's called the inverse of that. So if you look on your calculator, you'll find an inverse key on your calculator, and you'll take the inverse of both sides. Okay, so it's a little tricky, so please make sure you get your calculator out. Punch with me. Check a couple things. One, that your mode is correct. And then I want you to look at your calculator and notice that on top of the sine is this sine inverse key that I'm talking about. Okay, so basically when you want to find an angle, you'll use one of these three inverse keys to find an angle. Okay, so how do you punch that? You just hit second and then sine, and it will actually show up as a sine inverse, and then you just put in your opposite leg and your hypotenuse. What you'll get then is actually the value of theta. So if you take the inverse of the sine, this will cancel each other out and you'll be solving for the angle. When you take the sine inverse 11/14, what do you get? 51.8. And we're solving for an angle, so this should be degrees. Let's try another one. This triangle, I kind of switched it around a little bit, so it'd be harder to see what was the adjacent and hypotenuse and opposite leg. But let's see. Here's your right angle, so the side opposite the right angle is always the hypotenuse. We want to find theta, so the side next to theta is always your adjacent leg. So let's think, what trig function has adjacent and hypotenuse? Well, that's the cosine. So the cosine of theta equals adjacent over hypotenuse. Now, where's the math involved? Remember what we want to do. We want to find an angle. We want to find theta. So we want to get rid of this cosine of theta. And how do we do that? We take the opposite of that, which is called cosine inverse, and we take the cosine inverse of both sides. So again, this is a little tricky. You have to make sure that you know how to punch. And when would we do this? Write yourself a note. When finding an angle, you will always use a trig inverse key. Okay. Which trig inverse key? Well, it matters if you're doing sine or cosine or tangent. okay? But you'll use this trig inverse key, this sine inverse, or this cosine inverse, or this tangent inverse key, okay? So again, take a moment, highlight these in your notes. That'll kind of help you decide whether or not you should use the sine button or the sine inverse, okay? So in this case, again, take your calculator out. How do I know if I'm going to take the sine inverse, cosine inverse? Well, I want to get rid of the cosine. So I'm going to take the cosine inverse of adjacent over hypotenuse, and that value will be exactly what the angle is. Okay. So in number 3, let's try to first label the legs. So the legs that I'm giving here, if I'm looking at finding theta, I would label this 6 as opposite. The 11 is the one next to the angle, so that would be the adjacent leg. So again, looking at opposite and adjacent, I want to use the tangent function is opposite over adjacent. This is what I want to see in your notes. And then when you want to solve for theta, we're going to take the opposite of that, which is the tangent inverse, and then it just becomes a quick little punch. So tangent inverse of 6/11, your angle will be 28.6 degrees. So hit pause, take a second, make sure you're all caught up, and then I'll give you one that doesn't have the diagram. So first off, if we're given a problem and we don't see the picture, it's very important that you draw a quick sketch in. I saw that angle A was the right angle, so I put C was the right angle, so I put angle C here. We're asked to find B, so I just put angle B here. This would be the angle that we're finding. Angle B, you can stick in a theta in there if you want. And then let's label the other legs properly. Okay, remember if we're given little a is across from angle A. If we're given small case b, that b is across from angle B. So we would have a 10. Okay. So again, looking first at our picture, let's label using words opposite and adjacent. This leg I would use as the opposite leg. This leg is the adjacent leg. So it's pretty hard to do these without a picture. So I'll be asking you to show a picture, labeling the legs, and then let's look at what trig function I would use. Well, opposite and adjacent is the tangent. You can put tangent B or tangent theta, either one, is opposite over adjacent. And then think of what math is involved here. We want to get rid of the tangent function, so we tangent inverse both sides. That will get rid of it on here. We'll solve for theta. And what is that tangent inverse of 10/14? Rounded to the nearest tenth would be 35.5 degrees. So try problem 5. I'll turn the video back on when I have the right answers. And if you get the right answers, you can get your worksheet. If not, please check with me of why you didn't get the right answers. So I'll kind of walk you through the steps that you should have done. 1, you should have drawn your triangle. The right angle is C, so I put C in the corner here. A, I just chose to put here because it showed up first here. Side A is the one across from A. Side C is the one across from C. I was given the opposite and the hypotenuse leg, so I used the sine function. So when I took sine inverse of 7 over 9.1 is where I got 50.3. I then just used the idea that both these angles must add up to 90 degrees. And then to find the third leg, I just used Pythagorean's theorem.